Or so here's the difference. Say I give you two numbers, and don't write these down. 8 and 12, and I would ask you to find the GCF of 8 and 12. And you could get to the point now where you probably should be able to do it in your head. Okay? In fact, next week, the end of next week, a week from today, we're going to do a sprint on GCF to see if you can do it in your head. And I would give you numbers that are manageable. 8 and 12 are manageable numbers. What is the highest number that will go into both 8 and 12? Max. Correct. The GCF is 4. I'll just give you another for instance. What about if I give you 5 and 15? What's the GCF?
5.
See, you're doing it in your head, which is kind of really our ultimate goal. Because honestly, guys, GCF, the whole goal of doing GCF is to help you with fractions. Okay, so if I give you, let's say, 8/12 as a fraction, and I ask you either, and I could do it with ratios too, if I ask you find the value of that ratio, or simplify 8/12, what do you get? 2/3, right? What'd you divide by, Aunt?
4.
That's why we do GCF. See, GCF tells us what we need to divide by in order to get the value of the ratio or simplify the fraction into lowest terms. Anyway, going back to GCF and LCM, again, 4 is the greatest number that can go into both, right? What if I ask you this? What's the smallest number that 8 and 12 can go into?
Oh.
Again, what's the smallest number that 8 can go into and 12 can go into? Evenly. Evenly. There's only one number.
1. No.
No, because 8 can't go into 2. Think, 8 can't go into 2. 2 can go in 8. That's not what I'm asking. What's the smallest number that 8 can go into and 12 can go into? Now you got it. 24. Okay? That's called the LCM, or lowest common multiple. Okay? So now start thinking a little bit. Think, when we do GCF, can the GCF ever be greater than the higher number? Listen to my question. Can the GCF ever be higher than the higher number? No. Okay? So it's always, this number, the GCF, has to be within the range of 2 to 12 all the time. This will never be higher than 12. If I give you 5 and 15, the GCF is 5. Okay? It can never be higher or greater than the higher number. However, what do you notice about LCM? It's always what? Higher than
12.
the greater number, or always greater than the higher number. Okay? It could be equal to it. Watch. 4 and 8. First of all, what's the GCF? 4, right? What's the LCM?
8.
Right. It's the highest or the lowest number that both 4 can go into and 8 can go into. Well, 8 only goes into it once, but it still goes into it. If you think about it, let me know. On that note, now flip to the second page, which is really a recap of what we just did. Okay? So let's just put it into words so we have it down in our book. Yeah, Bridge. The greatest common factor, that's what it stands for. It means that that's the greatest factor, greatest number that can go into those numbers. So 8 and 12, the highest number that will go into 8 and 12 is 4. 5 can't go into 8, 6 can't go into 8, 7 can't go into 8. Well, 8 could go into 8, but it can't go into 12. Okay? So there's no number higher than 4 that will go into both. That's GCF. As a matter of fact, it's good that I recapped it because that's what we got to put into words now anyway. This is saying that 4 is the greatest number that goes into both 8 and 12. Don't you write that down. So I'll restate the question again because we kind of already did it. What's the smallest number that both 8 and 12 can go into? Even kind of already said it, but let's just say it again. Get it, Alex. 24. And that's called the lowest common multiple of both 8 and 12. That is the smallest number that goes into it. Now, Stephen, you came up with the original 24, right? Can I ask you a question? How did you figure it out? Tell me, what went through your head?
I thought about 3, but
You did it. You probably forgot how you even did it. What about you?
in my head.
Smiley, take. Yeah, you got it. Tell me how you would have done it.
I know that 12 times 2 is 24, and 8 times 3 is 24.
Okay.
So 12 can go into 24 only twice, so it can't go less than that. And so it could go into 2 and
All right. So she kind of said she took her 12 and said, okay, 12 times 2 is 24, and then did you say to yourself, well, can 8 go into 24? And it does. It goes 3 times. Okay. There's 3 different ways in which you could figure out LCM. What Smiley did is something called called skip count method, which I'm going to show to you in a minute. Charlie.
I usually like to write it down, but you can also do it in your head like 8. You can like kind of like test this out like 8, 16, 24.
Okay,
12.
Charlie's got it. That's called skip count. Count by 8s, count by 12s, and the first match you come to is your LCM. That's what skip count is, and I'm going to show it down to you. Give it as an example here. Two new numbers, 6 and 9. If we want to find out what's the smallest number that both 6 and 9 can go into, one method called method 1 is called skip count. You count by 6s, you count by 9s. What's the first match you come to? Ryan.
18.
I'm going to circle it. Circle it on your sheet as well. That is the LCM of 6 and 9. It's a good method. Okay? There's 3 methods. Inevitably, you're going to choose the one that works best for you. But what I've done is I've given you like a little recap of it, what I call advantages and disadvantages for each method. For method 1, if you choose to do skip count, that's great, but you need to know your times tables. You've got to be able to count by 6s and count by 9s. Because I tell you what, if you start counting by 6s, and then you're off by one number in the middle of that string, all of the other numbers are going to be off. So if you go 6, 12, 18, 26, I'm wrong at 26. And then you do 32, 38, they're all wrong after that one number that's incorrect. So if you're gonna count by those numbers, you've got to make sure you're accurate. If you know your times tables well, go for it. I always say, I tell my students, if the numbers I'm asking you to find LCM for are 12 or less, like 6 and 9, try to use skip count because I think you can do it. If I ask you, for instance, 17 and 18, it's a little difficult to start counting by 17s. Okay? Gets a little tricky. There's another way that you can do it. And now we'll go to method 2. What I want you to do, even if you could do it in your head, what's the GCF of 6 and 9? And if you don't know it in your head, go, by all means, go through the factor tree process.
3.
What is it? Agree, 3, right?
Yeah.
Okay, ready? Write that down.
Step ahead of you.
By the way, it's the same numbers in method 1. What was the LCM we've already found, just so we know it? 18. Just kind of put it up in the corner because we got to get that number with this second method as well. Okay, ready? You take the two numbers, the original numbers, 6 and 9, multiply it together.
I was right.
What do you get? 54, right? Method 2 says we can multiply the original numbers and divide it by the GCF. What do you get when you do 54 divided by 3? If you're not sure, do it off to the side.
I did it.
What do you get? 18. Ta-da! Same as what we got when we did skip count. Okay? So again, yeah, it is a lot faster. It can be. Sometimes it's not. Sometimes it's not. All right. So again, I'll give you another example. Let's do the LCM for. Let's do 8 and 12. Let's do it mentally. Look at me. What's the GCF of 8 and 12?
No.
GCF, not LCM. GCF. What's the highest number that goes into 8 and 12? We did it in the warm-up. 4, right? Okay. 12 times 8. Multiply the original numbers together. You may have to do it off to the side. 96. Method 2 is the GCF into the product of the numbers. 4 into 9 goes LCM of 8 and 12 is 24. Which we do it. We knew it because we did it already. Okay?
We just do it that way?
Method 2. I'm going to show you another method. Okay?
Wait, what's the disadvantage?
My idea is to expose you to all three. You pick what's best for you. And honestly, I did a survey in period 2 after I was done. 1/3 of the class did skip count. 1/3 of the class did it the way I just showed you. And 1/3 of the class chose to do it the way that I'm going to show you now. Advantages and disadvantages of what we just did. If you know how to do GCF, that's your starting block. It's good to use it. What you do have to watch out for is careless math errors. Okay, so if I ask you the LCM of 12 and 8, when you multiply 12 times 8, you better get that right. So you put down 72, your LCM's not going to be right. So you got to be careful. The other major disadvantage, not a major, minor, is that method 2 won't work when you're trying to find the LCM of 3 numbers, which sometimes you have to do. So if I give you 8, 10, and 15, I've got to find a number, the smallest number that all 3 can go into, you can't use method 2. So let me show you method 3, which will work for 3 numbers. Okay, same numbers. What was our LCM again so we don't forget for 6 and 9? 18. I want you to do factor tree. You do need to do factor trees for this because you're not finding GCF, but you do have to find the prime factors. So do that now. Break it down. Jack, come on up. Break it down and circle the bad boys.
Amazing Jack. What he's gonna do.
Circle those bad boys. You got it.
Trouble now.
Y'all get 3 and 2 for 6 and 3 and 3 for 9, right?
Yeah.
Okay, now at this point, we're not finding GCF, but watch what we're going to do. You want to stay up here or you want to sit?
I'll stay.
Okay, just move off to the side so I can write. All right. We'll start off like we normally do GCF. What do you see that's in both trees?
3.
Okay, cross it out, but list it once. What else? Anything else? No. Okay, what this is called, what's not crossed out, are called your leftovers. List the leftovers here. Every time you list it now, cross it out though. Cross it out up there. Okay. So LCM, using method 3, is the common factor, or factors, times the leftovers. So what's 3 times 2? Just say it.
6.
What's 6 times 3?
8.
Ta-da, that's your LCM, 18.
Wow.
Okay?
That is
And what's great about it is it will work with three numbers. Okay, advantages and disadvantages. You ready? This should be, since you already know how to do factor trees, this method is good. Cross it out. Just cross out GCF because you're not finding GCF with this.
You're finding something.
Okay, you're finding common factors, but not GCF. Disadvantages is using factor trees gets you started, but you have to practice knowing, and it can get a little confusing. You've got to make sure that you list your common factors once, and your leftovers get listed correctly as well. So you just got to be careful, and we're going to actually practice it coming up now with three numbers. Okay? Okay, Jack, have a seat, bud. Okay. One thing worth pointing out with LCM. If you have two numbers that do not have a GCF, or I shouldn't say a GCF, but no common factors. We covered this yesterday. If you have two numbers like 11 and 5, first of all, what's the GCF? 1, right? That's the highest number that goes into both. If they have no common factors, or they're prime, then in order to find LCM, what do you automatically do?
Multiply the two numbers together.
You multiply the two numbers together. So the LCM of 11 and 5 is 55. And by the way, 11 goes into 55 how many times? 5, which is the other factor. 5 goes into 55 how many times?
11 times.
Which is the other factor. Okay? All right, let's do LCM of three numbers. We can't use method 2, it won't work. But we can do 1 and 3. Let's first do skip count. Let's count by nines. Now, we don't know how many we're going to need. So count as many as you can
9, 18,
till you run out of gas.
9, 18, 25,
Keep going. Rattle them off for me.
45, 54, 63, 72, 81, 90.
I'm awesome.
Let's stop at 99. Maybe we make a match 3 ways before we get to it. Let's count by 15. It's a little bit more difficult.
30, 45, 60.
Let's stop. Because look, I have a potential match at 45. 18.
Oh, snap.
Oh, 18,
Help me out.
56, 50,
A little bit harder.
36.
A little bit harder. But look, see how I don't have a match at 45. I have a match at 90
We have 90.
and a 90 here.
Just multiply that by 40. 95.
But let's keep counting by 15s. We'll get there.
60, 60, 75, 75, and 90. Got it.
All right, there's my match.
Ooh, get that.
All right, LCM's 90.
So annoying.
Takes a little bit longer though with three numbers and an LCM of 90, right? Okay, method 3.
Oh, yeah, boy.
I need everybody to do a factor tree for 9, 15, and 18. I'll call somebody up. Method 3 is factor trees. It's not GCF. You got to find the prime factors and circle them.
Yeah. Is that all?
Bridge, you want to come up? Bridge, you've come up already. Has anybody never come up to Smartboard? See, you never come up? Come up.
Wait, I think he had.
He may have, but it's been a while.
No, I
All right, go ahead.
I remember I did it in October.
Circle those bad boys.
Liam. I don't think Liam had.
He's a silent partner in the business.
Yeah, I don't need a small board. That's his job.
Okay. Well, why don't you stay up here because you can write for us. As long as you broke down your 9 to 3 and 3, you'll still wind up at the same prime factors. Okay, ready? We're gonna talk Nick through this. Watch, because with three numbers it's a little different. Do you see a number that's in all 3 trees?
Yes, I do. Yeah.
Liam, which one? Cross out every 3 and list it once, Nick.
Where?
Underneath. 'Cause we need the room. Okay. Do you see another number in all 3 trees?
No.
Do you agree that we don't have another prime number in all 3? Okay, ready? Here's where, this is new, so watch. Is there a number that you see in 2 out of the 3 trees?
Yes. 3. Yeah.
Do you see the 3? It's in 2, but it's in 2? Cross them both out, but list it only once. Because it's still a common factor. It's not all by itself. Anything else in 2 trees?
No.
Okay, so we call these the common factors. This is the common.
10.
The ones that are not circled, or the ones that are circled that are not crossed out, are the leftovers. List them, Nick, and as you list it, cross it out.
Everyone likes Lindy. Lindy likes blue.
You know you're done when everything is crossed out. Now just multiply. What's 3 times 3?
9.
What's 2 times 5?
10.
What's 10 times 9?
90.
Bingo, that's what we got when we did skip count, 90.
If you did 9 times 2, it doesn't work.
I lost you, what?
I did 9 times 2.
Why 9 though?
Does work. 9 times 2, I did that, and I never got the 2.
9 times 2 is 18.
What?
9 times 2 is 18. 18 times 5 is 90.
Yeah.
So it works.
No.
Yeah, it does.
Anyway, listen, I'm recording, so let me tell you what we need to do, and then I'll take your individual questions. You have about 10 minutes. We have all of Monday to finish this up. So you guys, even my advanced, I want you to start off by doing the regulars. Every time you're done with a page, you need to show me. I want to make sure you're doing it. There have been a lot of mistakes, careless errors, so be careful.